Hi friends, welcome to my another video. Today in this video, I will discuss about the designing of final distribution board FDB. In this video, we will cover the selection of MCB, selection of ELCBs, selection of incomer and the DB enclosure itself for the final distribution board. We will design the final distribution board as per DEWA regulation. So we have to understand first some basics rule of the DEWA regulation which is related to final distribution board. So the first rule for the final distribution board as per DEWA regulation is that for the lighting circuit the MCB rating will be 10 ampere or 16 ampere only. For the power circuit the MCB rating will be 20 ampere, 25 ampere and 32 ampere. As per the DEWA regulation, the ELCB or RCCB sensitive rating for the light circuit will be 100 milliampere and the ELCB and RCCB sensitive rating for the power circuit is 30 milliampere. There are other some rules also. For the lighting circuit, the wire size is 2.5 square mm and for the power circuit, the minimum size will be 4 square mm. If the load is more, the load rating is more, then we can go for the higher size of cable also, like 6 square mm, 10 square mm or 16 square mm. And another rule for DEWA is till 3 kilowatt of single phase load we can go for 20 ampere MCB for the power circuit, and after 3 kilowatt we will go for 25 ampere MCB. It will be valid till 5 kilowatt. And the other rule in DEWA is that we can choose the 32 ampere of MCB when there is a ring circuit. Ring circuit means suppose this is the power sockets, and if there is 4 power socket, then we can take the power from DB and we can loop this power socket outlet, and this will be called radial circuit. But if the power sockets are more than 4, maybe 5, 6 or 7, 8 till 10, then we have to make ring circuit. In that case, one loop will again come back to the DB, and in that case we have to choose 32 ampere breaker rating for the ring circuit. Other than this, the next rule is that the ELCB rating will be twice of the maximum MCB rating. What does it mean? Suppose one ELCB is connected with 5 MCB. Okay, it is feeding 5 MCB and the rating of MCB is suppose 6 ampere, 10 ampere, 10 ampere, 16 ampere and 20 ampere. So which one is the biggest rating of MCB among all? This is 20 ampere. So the ELCB rating will be 2 into the maximum rating of MCB, that is 20. So the ELCB rating will be 40 ampere. Hope you got till here. Here I have taken one DEWA load schedule sample for 1 BHK flat, and there are some loads like lights, FCU, single sockets, water heater, window AC, split AC, hood, microwaves, refrigerator, dishwasher, washing machine. I will not tell you how to make this Excel sheet because it's not related to electrical part. If you know Excel, khalas, you can do it easily. The motto of this video is to know how to select MCB rating, how to select the ELCB rating, and how to select the main incomer isolator rating for the final distribution board. Here there are some circuits like R1, Y1, B1 till B9. So the first load which is in the kitchen, it is dishwasher, and the dishwasher load in watt is 2200 watt. So what would be the rating of MCB? As the load is 2200 watt, then the rating of the MCB will be 20 ampere. If the load for the single phase is more than 5 kilowatt, that is 5000 watt, then we can put the MCB rating as 25 ampere. As I already explained that as per the DEWA regulation, if the circuit is power circuit, then we can choose the MCB rating as 20 ampere, 25 ampere and 32 ampere. 20 ampere we will choose the MCB rating if the single phase load is less than 5000 watt. So in our case, the power load is 2200 watts, so we can choose the MCB rating as 20 ampere. Now let us move to other circuit, that is Y1. Y1 is feeding in the laundry area and the load is washing machine, which having a load of 250 watt. So as it is a power load and the load is less than 5000 watt, so we can choose here the rating of the MCB will be 20 ampere. Same for the B1 circuit, it is feeding in the living and dining area and this is feeding to force 13 ampere single socket. As I already told you that 113 ampere single socket load assume on it is 200 watt. So how many socket we have? 4 socket, and one socket assumed load on one socket is 200 watts. So the total watt on 13 ampere socket will be 200 into 4, that is 800 watt. So as the total load is less than 3000 watt, so we will use the breaker rating of MCB as 20 ampere. Any load which having the load less than 3000 watt, we will choose 20 ampere rating, and if the load is above 3000 to 4500 or 5000, then we will choose 25 ampere rating. Now let us move to the next circuit, that is R2. R2 is feeding in kitchen area, and on the R2 circuit there is 3 single socket of 13 ampere and 1 microwave. So as I told you, one socket the load assume is 200 watt and the microwave load is 150. So the total load on R2 circuit will be 3 into 200 plus 150. So it will came as 750. As the load is less than 3000 watt, so we will choose the breaker rating MCB rating as 20 ampere. I hope you now got the concept, so I will move fast now. Now let us move to the next circuit, that is B2. B2 has load of number of 13 ampere single socket. So the assumed load on one socket is 200 watt. So the total load on B2 will be 200 into 2, that is 400 watt. So the breaker rating MCB rating will be 20 ampere. The R3, Y3, B3 is a 3-phase circuit and it is feeding to one water heater which is having a load of 4500 ampere. If you will calculate the I from the 3-phase power formula, that is root 3 into V into I into cos phi, which I explained many times in my earlier video, then it will come as 8 ampere, around 8 ampere. So the next available breaker rating for the in triple pole is 20 ampere. So we will choose 20 ampere breaker here. If you have available size 16 ampere, then you can choose the 16 ampere breaker also. Now for the R4 is a space. I will tell you why we need to keep space in the DB, because it is also the requirement of Diva. Now let us move to Y4. Y4 has one refrigerator which having a load of 1200 watts. So the MCB rating for the Y4 will be 20 ampere. For B4 there is a 13 ampere socket. So each socket assumed load is 200 watt. So the total load on B4 circuit will be 1000 watt. As per the Diva regulation, till 4 socket it will be radial circuit, but after 4 sockets it will be ring circuit. So it is a ring circuit. So as I told you, as per the Diva, if there is a ring circuit, we need to choose 32 ampere breaker. Now let us move to other circuit, R5. R5 is in the feeding the entrance area and it is feeding FCUs. So 2 FCU. One FCU has 200 watt load and another FCU have 300 watt load. So total load on R5 circuit is 500. So we can choose the breaker size as 20 ampere. This is a space and another circuit is also a space. Let's move to R7. R7 is feeding to hood which having a total load of 50 watt only. Hood is coming in the light circuit. So the minimum size of the breaker, MCB breaker size for light is 10 ampere. So I put the MCB rating as 10 ampere for hood. Now Y6 is a space, so let us move to B6. B6 is feeding the master bedroom. In that master bedroom, B6 is feeding to the 2 chandelier light, 1 saver socket and 6 down lights. The rating of the chandelier light is 150 watt, for the down light is 50 watt and for the saver socket is 75 watt. So the total load on B6 will be 2 into 150, that is 300, plus 6 into 150, again it will be 300, so total 600, plus 1 into 75, so 600 plus 75, it will be 675. So the breaker rating will be 16 ampere, as it is a light circuit. For kitchen there is a 6 lights and each light have the power rating 50 watt. So 6 into 5, it will be 300 watts. So the breaker rating will be 16 ampere. Y7 is a space. Let us move to B7. B7 has 6 downlights and 1 strip light. The power rating for each downlight is 50 watt and the one strip light power rating is 25 watt. So the total load on B7 is 6 into 50, that is 300, plus 1 into 25 is equal to 25. So total will be 300 plus 25, it will be 325. So the light MCB rating for B7 is 16 ampere. R8 and Y8 is a space, so let us move to B8. B8 circuit is feeding the living area, and this living area has two type of light, chandelier light and downlight. There is 3 chandelier light and 1 downlight. The rating of the each chandelier light is 100 watt and the downlight power rating is 50 watt. So the total load on the B8 is 3 into 100 plus 1 into 50, so it will be 350. So the breaker rating will be for the light circuit is 16 ampere. Now let us move to the R9 is a space, so Y9. Y9, it is dishwasher, okay, one dishwasher which is having a power rating of 1600 watt. So the breaker rating will be 20 ampere, as it is a power load, so 20 ampere. And B9 is a space. I hope you got now very clearly that how to select the MCB size as per the DEWA regulation. Now let us move to select the ELCB size for as per the DEWA regulation. It is very easy. In this section, the breaker rating, the MCB breaker rating is 20 amperes, okay. So what we have to do, we have to multiply the MCB rating with 2. What will come? 20 into 2, that is 40 ampere. So the ELCB rating will be 40 ampere. Now we have to select the sensitivity rating of the ELCB or RCCB. As this section is feeding the power section, so as I told, the sensitivity rating for the power circuit is 30 milliampere. So I will write 30 milliampere. Now we selected the ELCB rating for section 1, that is 40 ampere, 30 milliampere. Now let us select the ELCB rating for section 2. As this section 2 is also feeding load, which is water heater, and the maximum MCB rating is 20 ampere. So the ELCB rating will be 20 into 2, that is 40 ampere, and the sensitivity rating will be 30 milliampere, as it is a power load. Now for section 3, as we see that the MCB rating is 32 and 20. So the maximum MCB rating is 32. So we will multiply 32 into 2. It came as 64 ampere. So our ELCB rating will be 63 ampere. And as it is a power load, so the sensitivity rating will be 30 milliampere. Sometime you will also find that instead of 63 ampere, the rating given as 40 ampere. So in that time, the minimum breaker rating is taken into the consideration and we will multiply that minimum breaker rating with 2. So in that case, 20 into 2 will be 40, so 40 ampere. It also can be used. Now let us move to the section 4. As the maximum breaker rating in the section 4 is 20 ampere, so the ELCB rating will be 20 into 2, that is 40 ampere, and as this load is feeding the power, so the sensitivity rating will be 30 milliampere. Hope you got this one. Now let us move to the section 5. In section 5 is a light circuit which I make in blue color. As you can see, as per the load also there is light and hoods. So this is the light circuit. So section 5 is a light circuit and the maximum breaker rating, MCB breaker rating is 16. So the ELCB rating will be 16 into 2, that is 32. So the ELCB breaker rating will be 32 ampere, and the sensitivity rating for the light circuit is 100 milliampere. Now let us move to the next section, that is section 6. In the section 6, the maximum rating of the MCB is 16 ampere. So the ELCB rating will be 2 into 16, that is 32 ampere, and the sensitivity rating will be 100 milliampere as it is a light circuit. So the ELCB rating will be 32 ampere, 100 milliampere for section 6. For section 7, it is a power section. So the minimum breaker rating is 20 ampere. So the ELCB rating will be 2 into 20, that is 40 ampere, and 30 milliampere as it is a power circuit. I hope now you got the idea how to select the MCB rating for every circuits and how to get the ELCB rating or RCCB rating for each section. Now our next motto is to select the isolator rating or the incomer rating for the final distribution board. In order to calculate the main breaker rating or main isolator rating of the final distribution board, we have to sum up the load on each phase. So we will sum up the load on R phase, load on Y phase, and load on B phase. So the load on R phase is 5300 watt, load on Y phase is 5750 watt, and load on B phase is 4950 watt. If we will sum up, then we will get the total load connected with this final distribution board. So the total connected load with this final distribution board is around 16 kilowatt. In order to know the isolator rating, it is simple. We have to use the power formula, that is P is equal to root 3 into V into I into cos phi. So the value of I will be P divided by root 3 into V into cos phi. As we know, the P is equal to 16 into 1000 watt divided by 1.732 into 415 volt as it is a 3 phase, and the power factor I consider as a 0.8. If we will multiply it, it will come as 27.84 ampere. So the next available isolator rating is 32 ampere and 40 ampere. As the incomer rating is the isolator rating, so even if we will choose the higher size of the isolator rating, there is no problem. But if we will select the incomer rating as a MCB, then we have to go for 32 ampere. But as the the incomer is isolator for the final distribution board, so I can choose the breaker rating as 40 ampere triple pole isolator. So far we selected the MCB rating, ELCB rating, and the main incomer isolator rating. Now the final part is to select the enclosure size for this final distribution board. It is very easy. Now, in order to know in deep how to select the enclosure size for a final distribution board, watch my video, link will be in the description. But in short, I will tell you here, and inshallah you will understand it better. In order to size the enclosure of the final distribution board, we have to count the modules, number of modules, and one module is equal to one single pole MCB. So how many single pole MCB we have? Total 27 single pole MCB, including the spaces. Spaces also we need to consider, because in future if the load will increase or the load extension will occur, then these spaces will fill with the single pole MCB. So how many the MCCB will have? 27 MCB. So 27 MCB means 27 modules. So I will write 27 MCB single pole. Now how many ELCB we have? There is total 7 section. So there is total 7 ELCB. So the total 7 ELCB, and ELCB is coming in 4 pole. Okay. How many incomer breaker we have? Isolator we have 1. That is 40 ampere 3 pole. So we will write here one isolator, three pole. So how many module for MCB? It is 27 module. For the ELCB it will be 4 into 7, 28 module, and for isolator it will be 3 modules. Hope you got till here. Now let us see that is there any contactor or UV relay for the FCU. Here you can see that there is FCU. So let us check that there is any contactor or UV relay or not. Here not mentioned, but as per the DEWA regulation, we need for each FCU UV relay and the contactor. For each set of UV relay and contactor we consider 4 modules. So there is 2 FCU. So for FCU there will be 2 set of contactor plus UV relay, which will be considered as 4 modules. So 2 into 4, it will be 8 module. So how many modules we have now? 27 plus 28 plus 3 plus 8. If we will sum this all module, that is 27 module plus 28 module plus 3 module plus 8 module, then it will come as 66 module. As we know that in Diva, in Dubai, there is popular final distribution board is a row type distribution board. If you know how many type of distribution board is there as per the breaker arrangement, then watch my video, link will be in the description. So in Diva, the final distribution board is of row type. So we have following options like 4 row into 16 module, but 4 into 16 is coming 64 module, so which is less than our requirement. So we cannot use 4 into 16 module enclosure for the final distribution board. The other option is I can go for 5 into 16 row module. So 5 into 16, how much? 5 into 16 is equal to 80. So we can go for 5 row 16 module final distribution board enclosure, or we can go for 3 into 24. 3 into 24, how much? 3 into 24, it is coming as 72. So this is also more than our required modules. So we can go for 3 row 24 module final distribution board also. So either we can go for 5 row 16 module or 3 row 24 module final distribution board enclosure. Hope you got the concept how to design the final distribution board, how to select the MCB rating, how to select the ELCB rating, how to select the incomer rating, and finally how to select the enclosure size of the final distribution board. If you find this video informative, then please subscribe to my channel, give thumbs up to this video and share with your friend. We will meet in any other informative video. Till then, take care, keep learning, and bye bye. Thank you so much.